Hello everyone. Now, in the last session, we have discussed that second part of memory interfacing, right? And what are the basic decoding techniques through which memory interfacing can be done. Now, this is the memory final part with examples of memory interfacing with 8085, right? Here, now we will see two basic examples in which all will be included, that how memory can be interfaced with 8085 and how the questions and the solutions can be find out. Right now, let's take example 1. So the question for example 1, that is, design a memory system that contains 4 KB of ROM, use all address lines, use any combination of inverter, NAND gate and 74LS318 decoder to generate address. Determine memory map of the design. Right now, let's go to this solution. What it has been given. So we have taken this basic example. So only ROM has been given, which is having a memory of 4 KB. So we need to interface 4 KB of ROM with the 8085. And here we need to use all 16 address lines. That means we need to use absolute decoding technique. Right now, you can use for the rest of the address lines, we can use any combination of inverter, NAND gate or the decoder circuit. Right, and what we need to show is memory mapping of that particular design. Now let's go to the solution. So the solution for this this question or this example is as follows. So what is the step 1? So the step 1 is total EPROM required, that is 4 KB. Clear? Now here we have taken an assumption that chip size is also available. IC of 4 KB is available. It is taken as assumption. If it is not given in any question, so we have taken an exception, that is 4 KB. If it is given in question that we need to use 2 KB of IC, then we need to use 2 ROMs which are connected successively, right? Thus the number of chip required will be 4 KB, that is total ROM required, divided by size of each chip, that is 4 KB. So we will require total 1 number of chips, right? So this is the step 1. Now in step 2, what we need to find is, that is, we need to find the ending address and starting address. So as we have studied in the important points, that the starting address of the ROM should be always 000H. Now the chip size is 4 KB, right? So if we define how 4 KB can be 4 can be represented in 16 bits, so it will be 0FFH. Clear? So thus the ending address will be the starting address plus this chip size, so this will be the ending address. So 0000H plus 0FFFH, so it will be 0FFFH. Clear? Right? So this is the which we have find first, that is how many chips are required, what is the starting address, and based on this chip size we have find out the ending address. Now in step 2 we will show the memory mapping. Now as soon as you can see, this is ROM, we are using chip 1 only. The starting address is 000H and we need to use all 16 address lines. So here it is shown from A0 to A15, all are zeros, as it is 0000H starting address. Right now the ending address is what if you don't know how to find ending address, then do this memory mapping first. Clear? How you can do is, you need to store 4 KB. So 4 KB, when it will be 4 KB, so how many address lines will be required? 12 address lines will be required. That is 2 raised to 12, that is 4096. Clear? That is 4 KB. So 12 address lines will require. So when we start from A0, so A0 to A11 will be required address lines. So the ending address can be find out by enabling from 0 of starting address to 1 in the ending address. So in ending address, what we will do? We will do A0 to A11, which we are using for ROM as a memory address, that will be enabled by 1. And rest of the pins, that is A12, A13, A14 and A15, these will be copied from the starting address same as it is. Right? Now from this square shown below, what we need to do is, we need to apply a decoding logic. So what all the pins are 0, so we can say that it is a Y0 bar. Right? Now how This is the final implementation with 808. Now, see, this is the 8085 pin. This is the basic structure in which we have seen the pin diagram, right? So this structure you need to do in every, you need to draw in each and every diagram, right? The rest will be changed over here only, right? Now, what do you, this is the pin diagram. Here VCC plus 5 volt connected, ground connected, X1, X2 connected with the crystal, right? Resetting connected with the bar, right? Then again the rest of the pins are shown over here. The right now interrupt are not used, so all are ground, right? Now here what we have shown a higher order address bus which is A8 to A50, which pass on over here. Now AD0 to AD7, which will be demultiplexed using this IC. So this IC will be enabled using address latch enable signal. So from this here A0 to A7 mixed with A8 to A15, so it will be A0 to 815, and this rest of the address lines are used as a data bus. Clear? Now here we need to memory connect a memory of 1 KB. So 4 KB. So 4 KB will have a address lines of 11, A0 to 11. So A0 to A11 will be given over here from A0 to A15. And as it is a ROM, so this memory read will be object enabled, right? And data will be transferred over here. Clear? Now here chip select. So the rest of the data address lines A12, A13, A14 and A15 will be passed from this decoder IC. As it is 4 inputs, so 4:16, right? 2 raised to n output, so 2 raised to 4, that is 16. So we will have Y0 to Y15, in which Y0, as all the pins are 0, so Y0 bar will be used for the chip select. So here written as X, and X is a given input as chip select. Clear? So whenever you are doing, or whenever any memory mapping example is asked in an exam, this part of pin diagram of 8085 you have to shown as it is. What will be changed here? How much the KB of memory you need to connect, this will be only changed, right? Now rest of the things will be as it is. Clear? So this is the example 1. Now moving on to same, we are going to study with example 2. Now what does the example 2 says? So design a memory system that connects 2 KB of ROM, immediately followed by 1 KB of RAM. So 2 KB of ROM is connected, and after the ROM is completed, the next from the next location the RAM will be started, which is of 1 KB. Now the ROM starts at an address from initial address, which is 000H, and it is implemented using 1 KB of the chip size given is 1 KB, and how much we need to implement, that is 2 KB. So how many chips will be required? 2 number of chips we will require will be 2. The read rate memory is implemented using 1 KB. So chip size is 1 KB, and 1 KB we need to implement, so number of chips will be 1. And similarly use decoder and gates for interfacing circuits. Now we will see the solution of this question one by one. So this is the first step. We need to calculate number of chips. So total number of EPROM required 2 KB. Chip size is available, that is 1 KB. So total number of chips will be 2 KB by 1 KB, that is equal to 2. So 2 ROM will be connected successively, and after 2 ROMs 1 RAM will be connected. Now we will find the starting address. So for chip 1 there are 2 chips. So for chip 1 the starting address is 00H. So it is 1 KB. So 1 KB, as you can, if you don't know how to calculate, then for 1 KB how many address lines are required? 1 KB, that is 1024, so A0 to A9. So enable A0 to A9 in memory map and find out the ending address, which is 03FFH. So the ending address will be what? 00 plus this, that will be final ending address. Now this is the chip 1. Now chip 2 of ROM, where it will be started from the next location of this. So what we have to do? We have to add these in 1. So if consider 3FF. Here in the place of FF, if we want to make it easy for decimal system, it is, let's say it is 399. F, that is the last number of hexadecimal, which is the last number of decimal, that is 9. So consider 399. So 399 plus 1, that will be equal to 400, right? So the starting address of next ROM will be this plus 1, so it will be equal to 400H, right? Again, chip size is 1 KB, so the address will be this, and the ending address will be the starting address, that is 0400H plus 03FFH. So it will be 07FFH, right? So this is for the row. Now, step 2 for RAM. So total RAM required, that is equal to 1 KB. Chip size available, that is equal to 1 KB. So number of chips required will be equal to 1. Now, this RAM is followed by the ROM, right? So again, what is the ending address of ROM? That is 07FF. If we add this in, if we add 1 in this, it will be 0800. So the address, starting address will be 0800. Right? Again, 1 KB, so ending address will be this, so 0800 plus 03FF. So 8 plus 3, that is 11. In 11 in hexadecimal, that is B. So 0BFFH. Right? So here we have find out a starting and ending address of ROM and RAM. Now, in second table, we will do the implementation, which is memory mapping. So this is the ROM chip 1, right? Here starting address is 0. So from A0 to A15, all are 0. And ending address for this, that will be used for how many chips are used for, that is A0 to A9. So A0 to A9 will be 1, rest all will be 0. But if we want to use partial decoding, then we can change this particular chip, right? So while using this decoding logic, what it will happen? So it will be Y0 dot Y3, right? That means this is the ending of, this is first starting address, that is Y0, all are zeros, and this is in binary it is 3. So Y0 and Y3 AND gate, right? Same way chip 2. So chip 2, how will be selected? So and starting address will be 400. So starting address will be 400 written over here, and ending address will be this. So ending address will be this, and rest of the pins are reflected over here. So it will be in binary, both are same, that is 1. So it will be Y1, right? If you don't want to keep on, then it will be a Y0. That is okay. Clear? It is up to you what the decoding logic you are applying here. It will be differentiate by student to student. Clear? Now RAM 1, again it is after this plus 1, so A0800. So 0800 is implemented over here, and again it is 1 B key, so it will be this and this, so it will be Y2, right? So here Y0 dot Y3, Y1 and Y2. Right? You can keep Y0 only, right? If you want to make it easy, don't enable these two pins, make it 00 only. Clear? Now this is the final implementation. So as you can see, as I have told, that this will be same as it is, right? Now what we need to show is, we need to successive consecutive 2 ROMs. So this is 2 ROMs of 1 KB, and this is 1 RAM of again 1 KB. All are 1 KB. So all address lines from A0 to A9 will all be selected, right? So all has been passed through only 1 line. Now data can be given from data bus. So data bus has been passed. Now this read signal will be connected to object enable of both the ROMs, and here a read signal will be connected to RAM object enable, and write signal will be also connected to write enable. Right? Now the rest of the decoding, that is from A10 to A15, are given to the decoder, and it will generate the decoding logic. In this, the first was the AND gate of Y0 and Y3. So Y0 and Y3 will be AND gate, and here it is given at the 1 chip. Then second, for second, that is ROM, that is Y1. So Y1 will be given over here, and for RAM it will be a Y2. So Y2 it will be input given over here, right? Understood? Right? Now you can follow. This. I will send you the notes of this particular examples. Right? There are many examples given in the notes. Right? I will give you the notes. Right? And based on that, you will solve another examples too. Clear? Right? So that's all for today's session. Here we stop ending our session, and as well as we have completed our memory interfacing topic over here. Now next we will go towards the microcontroller 8081. Thank you.